Hi, Stuart Box here from Sigma, and we're going to have 3 short demonstrations for products that are related to bolted flange connections. But as an intro, I wanted to start with the most important thing that's associated with all flange installations, and that is to verify that your flange face is both clean and free of debris, as well as having no mechanical damage across the face of the flange. If this flange had been thrown and dinged up against the pipe and there was a score across the face of the flange, that could allow leakage from the inside to the outside. So clean, no debris on the face, as well as no mechanical damage to the sealing area. The sealing area on a flange occurs between the bolt and the inside of the pipe. The area on outside of the bolt is not necessary for sealing. So concentrate your efforts between the bolt holes and the inside of the pipe. So hope you enjoy the next 3 demonstration videos. Hello, Stuart Box here from Sigma, and today we're going to discuss 2 similar topics, slightly different products, but using the same components. I have the accoutrements here I need for both of those demonstrations. I'm going to start with the flange connection. The other connection that we're going to discuss today is the Flange by MJ adapter, and Sigma calls that the SFA, the Sigma Flange Adapter. So as I said, I'm going to start with the flange fitting connection. Flange fittings and mechanical joint fittings are similar in that they have a flange. They have bolts that compress a gasket. But a flange connection doesn't use something like an MJ gasket, which we discussed previously. This is an MJ gasket. It's a big, heavy rubber gasket. In the flange connection, this is the gasket. It's typically a 1/8 inch piece of red rubber, and the compression of the bolts squeezes the gasket between 2 flanges. It's really quite simple. The flange for Sigma fittings conforms to AWWA C110 from a dimensional standpoint, and I'm going to demonstrate very simply the installation of a blind flange against a flange fitting. To start, you install 2 bolts on the bottom, and this will allow you to put your flange in place against the gasket. And I like to put 2 nuts on to hold that so that it doesn't fall off. By the way, this is a Sigma flange gasket kit. We call it an FGP for flange gasket pack, and it has everything in it that you'll need to make a standard flange connection. So, as I said, it's really quite simple. Gasket, bolts, and nuts. I don't think I'm going to go through the process of showing you how to put all this together. It really is very, very simple. We do recommend that once you have all the bolts hand tight, that you use a star pattern to tighten the nuts as you go around. Surprisingly, there is no AWWA standard for the torque to be used on these particular bolts. It's necessary to torque the bolt until you get the gasket compressed enough to prevent a leak. Typically, we like something around 75 to 100 foot-pounds, depending on the size of the bolt. But if you need a specific recommendation, we can provide it, even though it's not specifically called out in the standard. And that's really all there is to installing a flange gasket between two flange faces. Obviously, it's much more difficult the bigger you get, and out in the field where you're having to hold up a piece of pipe maybe, or a big fitting. It's not quite as easy as what I showed you here on the table, but the process is exactly the same. Okay, so I've set aside the blind flange and the red rubber gasket that would be used in the standard connection, and now I'm going to demonstrate the proper installation of a SFA, Sigma Flange adapter. A Sigma Flange adapter would be used when you have a connection going from an underground portion of a treatment plant, let's say, where you have mechanical joint underground, and when you breach the building or come up through the floor, or however the design engineer has decided to do it, you have to convert to a flange fitting from an MJ. So, or from a piece of pipe that was not a flange pipe and doesn't have a flange connection. It's just a blank flange like you see on the end of this pipe. How do we connect to the end of this pipe? It's now sticking up through the floor in a building. What do? Well, the fitting's not an MJ. We're going to go with a flange fitting. We got to convert from the piece of pipe to the flange fitting. So we do that using a flange adapter. The flange adapter doesn't require the gasket because we have an O-ring that's glued into the face of the flange at the manufacturer. The bolts and the nuts are the same. There's really nothing very complicated about making this connection. I like to start in the same way, and that is with the bolts down low so that it's holding the part up as I get started with the next connection. Install a few nuts, and then we can connect this to the pipeline. I have installed all of the hex bolts and nuts and tightened them down in a star pattern on the connection between the flange and the Sigma Flange adapter. Again, there's an O-ring in here that's being compressed rather than a red rubber gasket in a typical flange connection. I'll use the appropriate hand tools to do that. Torque is, again, not specified in the standard, but we like to use around 75 foot-pounds. The connection to the pipe is quite simple now. It's exactly the same process that we used in a previous demonstration where we showed you how to use a restraint, how to install a restraint. We now have a mechanical joint connection that probably requires restraint. It may not need to be restrained, but typically these type of connections do. So I'm going to demonstrate just simply how to do that. Please be aware that the MJ, the flange, corresponds to the dimensions in C110 for the flange fittings on the flange side. On the MJ side, these dimensions conform to AWWA C111. The connection, again, is the same as a restraint for PVC pipe as I'm demonstrating here, or it could be a piece of ductile. Either way, you can use an SLC product, SLCE product, or an SLDE product in conjunction with this device. So once you have your flange attached to your flange adapter, you mount a piece of pipe. It can go as deep as you need it to. It doesn't really matter. The depth of penetration is not that important as long as you get a stab depth equal to the distance inside the pipe to the pipe stop, which you can see in here. It shows in our product literature. In this particular case, it's about 2 inches. So as long as the pipe is inside the flange adapter a couple of inches, you compress the gasket in the same method that we've discussed previously with the restraint installation. And there you have a conversion from a piece of pipe without a flange to a flange connection that can be carried on throughout the pipeline in an above ground installation. I hope that was informative for you. Thank you. Hey, Stuart, back again with you, and Today I'm going to describe the installation of what we call a zip flange. It's also known in the industry as a flange adapter. It can be used to convert a piece of plain end ductile iron pipe to a flange connection. This product is not for use on PVC. It is only for use on ductile. And again, what we're trying to do is to go from a piece of pipe that doesn't have a bell to a flange fitting. How do we do that? Well, we need a flange face, and we also need to make sure that whatever we put on the piece of pipe doesn't slip off. So Sigma has created what we call the zip flange. The zip flange consists of a flange that has the bolt characteristics and bolt pattern consistent with AWWA C110 with a built-in MJ gasket, standard MJ gasket, that fits in a gasket seat that conforms to AWWA C111 with one small exception, and that is that the seat is not as deep as you would find on a typical MJ bell, which allows the gasket to protrude between the flange faces and creates your seal. The way to install this is quite simple. You place the set screws in on the pipe first. You install your gasket with the gasket bevel facing the zip flange, because it's going to seat inside the zip flange. Obviously, this should be clean and free of debris when you do that. Then the zip flange is brought up to the gasket, and the gasket is, I got a little bit too far from the end. I'm going to install this on a blind flange, so the gasket should be fairly close to the end of the pipe so that the pipe doesn't protrude through very much. And you use a standard flange bolt kit without the red rubber gasket. And what's going to happen is as all this is tightened, all these bolts are tightened down, the MJ gasket that you can see sticking up in here between the surfaces, I think you can probably see there's an MJ gasket. I'm going to pull all that in place so that the gasket seals between the zip flange and the fitting flange. This happens to be a blind flange because it's just easy to install. Okay, so I've installed the standard flange bolts, and I have used a star pattern to tighten those bolts and have reached a reasonably high torque value of around 75 foot-pounds. It's not specified in the standard, but we find that that's a consistent number that is fairly easy to reach and gives us good results. The gasket is now compressed. The MJ gasket is now compressed between the zip flange and the flange fitting. And all that's left to do is tighten the set screws that will hold the zip flange in place on the end of the pipe. I want to show you the tip of the set screw. This is not any standard set screw. This set screw has both a cupped point and a knurled point, which gives it the proper bite into the ductile iron pipe. It's also why it won't work on PVC. It'll actually crack the PVC. But the ductile pipe is strong enough to actually allow this set screw point to dig in and hold. It's a little bit like our restraint, but also different in that it's not a wedge action, it's just a pointed set screw. So in our literature, you will find the recommended torque for these set screws. It's important that you achieve at least the recommended torque, or what will happen is the zip flange will slip off the end of the pipe and you'll have a leak. So again, the torque values are listed in our website, and at a bare minimum you should use what's included in our literature. Very good. Thank you for your help today and your time. So hi, it's Stuart Box and I'm here with Laurie, and you watched the bolted flange connection video that we did. Did you have some questions?
I have a couple questions. Is there a controlling AWWA specification for the SFA and the zip flange?
The devices themselves are not covered by any AWWA specification. However, the connections are specified in both C110 and C111. So the connection conforms to the standard. The product itself is not something that is specified in the standard.
Can you use an SFA on a PVC pipe?
You can use a Sigma flange adapter on a PVC pipe, yes.
How about the zip flange?
You cannot use a zip flange on a piece of PVC pipe,
So that can only be used on ductile?
only on ductile.
Okay, well thanks.